Now let's move to the second part of the video in which we are solving the commutator. So we have already solved 5 questions. Now 5 questions were left. So now in this video we will complete it and let's start it. So the sixth question is, consider the operator alpha is equal to x plus dx acting on a smooth function of x. So here x is a smooth function. Then the commutator alpha cos alpha is. So what will be the alpha cos alpha? So we can solve it. So alpha cos x is equal to x plus dx, d upon dx cos x. So we can write it as x cos x plus d upon dx cos x. So as this is a smooth function, so this commutation should be 0. So this will give us 0. And then what we are left with, d upon dx cos x. So now expand it. D upon dx cos x minus cos x d upon dx. So how do we get the solution? So as we know, what is the use of operator? So we use operator to operate on a wave function to get a physical quantities. So what are the operators? Like Hamiltonian, we use Hamiltonian to operate on wave function to get eigenenergies, and like momentum operator to give momentum, velocity operator to give the velocity. Similarly, now to solve this solve this operation, we will apply it on a wave function. Then we will get the solution. So when we apply it on a wave function, we can write it as d upon dx cos x minus cos x d upon dx. Let's arbitrary wave function psi. When we apply it on psi, this will becomes d upon dx cos x psi minus cos x d upon dx psi. So this will give us a bracket d upon dx cos x psi plus cos x psi. So cos x d upon dx psi minus cos x d upon dx psi. So this will go to 0. This is cancel out. So what we are left with, d upon dx cos x psi. This will be derivative of differentiation of cos x will give minus sin x psi. So as the operator operated on wave function will give minus sin x, so the solution will be minus sin x. So let's see the option here, A. This is the answer. Now let's solve the question number 7. Here we can see what this question were asked in December 2017, and the question is, let x denote the position operator and p the canonically conjugate momentum. So x is the position and its conjugate momentum is p of a particle, and the commutator is given by 1 upon twice m p square plus beta x square and 1 upon m p square plus gamma x square. And beta and gamma are constants. So we have to find the value of beta and gamma such that the commutator will be, this should be 0. So let's find the solution. So here 1 upon twice m p square plus beta, plus beta x square 1 upon m p square plus gamma x square should be 0. So now we can write this commutation in the simplest form by separating the summation. So here we use a trick like we know commutation between p square or momentum with momentum is 0 and position with position will be 0. So we will use cross term. So we will take momentum with position all the time. Here momentum with this position and this position with this momentum. So let's write it 1 upon twice m p square gamma x square plus other parts will be 0 and beta x square 1 upon m p square is equal to 0. So now we can, these are the constant terms, we can take it outside. Gamma by twice m p square x square plus beta by m x square p square is equal to 0. So we can see these are two commutators and just multiplying minus with this commutation will give will inverse this commutation, like x square p square will change to p square x square. So gamma by twice m p square x square, taking minus 1 outside, beta by m, we can write it as p square x square is equal to 0. So now both the commutators are same, so we can take it common. Gamma by twice m minus beta by m p square x square is equal to 0. So here the commutation is for position and momentum and position. So this commutation will not be 0 because when we solve it, it will give us in the term of IH cut, because the commutation of x and p will be IH cut. So this part will not be 0. So we are left with the constant part. So this part must be 0, then the commutation will be 0. So we can write 1 upon gamma upon twice m minus beta upon m is equal to 0. So this will give gamma upon twice m is equal to beta upon m, m cancel out. So gamma is equal to twice m. So this should be the solution, gamma is equal to twice m b. B should be the solution. Now let's start solving question number 8. This question was asked in December 2018. The question is, consider the operator AX. So AX is an operator is equal to Ly Pz minus Lz Py. Combination of two operators, which is one is angular momentum and another is linear momentum or momentum. So where Li and Pi denotes the component of angular momentum and momentum operators. The commutator Ax and x, where x is the x component of position operator is. So here we have to find the commutator of Ax x. So the solution will be Ax x is equal to Ly Pz minus Lz Py x. So we can break it Ly Pz x minus Lz Py x. Now just looking at this, we can see when we break it, the part which has commutation Pz and x. So the Pz x commutation is 0. So we will left with only Ly x and Pz will come out minus again here Py commutation of Py with x is 0. So again here we are left with Lz x Py will come out. Now we will expand Ly and Lz. So Ly is equal to Z Px minus xpz and Lz is equal to xpy minus ypx. So now putting the value of Ly and Lz in previous term, this term. So here we will get Z Px minus x Pz commutation with x will give P and Pz minus x Py minus ypx commutation with x Py. Again, we can see here the commutation of x with x and Pz will be 0. So second term will, so the commutation with second term will be 0. So we can directly neglect it, and the commutation of x and Px will exist. So we can directly write Z Px x Pz minus, again here the commutation of x with x and Py is 0. So first term will be 0. So we are left with y Px x Py. Now the next term is, so here commutation of x with z is 0. So we are left with z. We can take z outside. Px x Pz minus, this minus will come out, so it will be plus, and commutation of x with y is 0. So we can take y outside. Px x Py, and we know Pxx is minus I h cat minus I h cat. So taking minus I h cat outside, we are left with z Pz plus y Py. So just we will look at the solution. So minus h cat z. So the solution is A minus z I h cat z Pz plus y Py. Now let's solve question number 9. So here This question were asked in July 2024. The question is here: if A and B are Hermitian operators and C is an anti-Hermitian operator, then ABC is Hermitian or ACB is anti-Hermitian. So the question we have to find this part and this part, whether these are Hermitian or anti-Hermitian. So let's solve it. So first part is A, B, C. So taking the Hermitian of this operator is A, B. Now break it, A, B, C minus C, A, B, whole dagger. So when we take the dagger of all this, then this will be C dagger A, B dagger minus A, B dagger C dagger. So both term has AB dagger. So let's first solve it. What is A commutation of AB dagger is AB minus BA dagger. So this will give B dagger A dagger minus A dagger B dagger. So A and B is Hermitian, so we can write it as BA minus AB. We can take minus outside, AB minus BA. This will further give me AB. AB dagger is AB dagger is minus AB. So now we will put this in this equation. We will get C dagger is minus C minus AB minus A B commutation of AB minus C. So this will give C AB minus AB C. So now what we take minus outside, it will be AB C minus C AB. So we can further write it AB commutation of AB with commutation of C. So the first term is anti-Hermitian. Now let's go to second term. So what is second term? Second term is ACB. So ACB, taking dagger of this will give ACB minus BAC. A whole dagger will give B dagger AC dagger minus AC dagger B dagger So B dagger, AC dagger is, this is, so here AC dagger will be A AC minus CA whole dagger. So C dagger A dagger minus A dagger C dagger is minus C dagger is anti-Hermitian, so C dagger is C is anti-Hermitian, so C dagger is minus C A plus A C. So this will give AC minus CA. So this is AC. Now putting this in this equation, we will get B dagger is B, AC dagger is AC minus AC B. So taking minus outside, it will give A C B minus B A C. Sorry. So this is minus A C B. So this is also anti-Hermitian. So the option is Hermitian, anti-Hermitian. Yeah, both are anti-Hermitian. So option is B. Now let's solve the last question of this topic, commutator. So this question was asked in July 2024. The question is, if L is the orbital angular momentum operator and sigma are the Pauli matrices. So L is the orbital angular momentum and sigma Pauli matrices. Which of the following operator commute with sigma dot L? So what we have to find is, there are four options A, B, C, D. Which of them commute with sigma dot L? So this will be a tedious task to calculate individually for each operator. So it will be take very long time. So here what we can see, we will try to find the similarity between the options. So it has few similarities, like operator L, first part is common in all of them, and sigma is common in all the options. Only the part is this constant part. In all the options, this constant part is different. So we can simplify it by writing L plus C sigma. Now we will try to find the commutation of this part with this should be 0. Then from there we will find the value of C, and from there we will get the solution. So let's try to find this. We can write here sigma dot L plus C sigma should be 0. So now break it. Sigma dot L with L plus, we can take outside, sigma dot L sigma. So sigma dot L is sigma x Lx plus sigma y Ly plus sigma z Lz. So this is a scalar value, and L is vector. So here we are trying to find uh, a scalar operator, or we can say scalar values commute with the vector. So a scalar operator with vector, or we can say operator. Now let's find first this part, and then we will solve this part and then add it and put it in this equation, and we'll get the solution. So sigma dot L is sigma xlx plus sigma yly plus sigma zlz lx I cap plus ly j cap plus lz k cap. So now we will break it. So sigma x lx and lx will commute, so this part will be 0. So because sigma x commute with lx and lx commute with lx, so this part will be 0. So we will directly write sigma y ly lx I cap plus sigma z lz lx I cap. Now another term, sigma x lx and ly, sigma x lx ly j cap plus second part, again this will be 0. The commutation with sigma y ly and ly is 0. So we will directly go to third part, sigma z lz ly j cap plus, now we will go to sigma z lz, sorry, sigma x lx with lz. We have to be very cautious here. K cap plus sigma y ly lz k cap. Now from here what we will get, sigma y and sigma y and lx will commute. So we will take sigma y outside. Here ly and lx we will left out with ly and lx. So commutation of ly lx will give minus I h cut lz I cap plus second part sigma z, again we will take outside. Lz lx will give I h cat ly I cap plus sigma x lx. Again sigma x we will take out lx and ly. Lx and ly will give I h cat lz j cap plus lz and ly. Lz and ly will give minus I h cat lx j cap plus sigma x, Lx and Lz will give minus I h cat Ly k cap plus here Ly and Lz will give Ly and I h cat Lx. Okay, very nice. So now take the component or I component, j component, and k component cumulatively. So here we take I h cut common. This will give us sigma z ly minus sigma y lz I cap plus sigma x lz minus sigma z lx j cap plus sigma y lx minus sigma x ly k cap. So we can write here I h cat. We can take it as a x a y and a z, and we can write it as I h cat a. Okay, in the vector form. Now let's go to second part. So what is second part? Sigma dot L and sigma. So sigma dot L sigma. This will give, again we can break it, sigma x Lx plus sigma y Ly plus sigma z Lz sigma x I cap plus sigma y j cap plus sigma z k cap. Now again we can write here sigma x will be 0 and sigma x Lx will be 0. So here first part we can neglect. We can take second part and take Ly outside it. So the sigma y and sigma x will give, just write it, then it will be a simplified form. Sigma y Ly sigma x I cap plus sigma z Lz sigma x I cap plus, now we will go for the jth component, sigma x Lx sigma y j cap plus second term will be 0, sigma y Ly commute with sigma y, so this term will be 0. And then go to third term, sigma z Lz sigma y j cap plus sigma x Lx sigma z k cap plus sigma y Ly sigma z k cap. Now let's solve it. This is now very simplified. So we can take Ly outside of the commutator because L or vital angular momentum commute with spin. So we take sigma y sigma x Ly. So just directly write the values. Otherwise it will take very long time. So sigma y sigma x will give, as we know, minus. Just write the few terms. Sigma x sigma y will give twice I sigma z. Similarly, this is cyclical, so similarly we can find other terms. uh, X y z, we can write this is cyclical term. So as we change the position of x and y, then the z, we will get different position of z will change. So here we can write sigma y ly. So here the first term will be sigma y lx, sigma y lx. So minus twice I sigma z ly I cap plus sigma z lx. We give twice I sigma y lz I cap. Now second term will be uh, third term. So here sigma x sigma y will give twice I sigma z lx j cap plus sigma z sigma y will give minus twice I sigma x lz j cap, and sigma x sigma z will give minus twice I sigma y lx k cap plus sigma y sigma z will give twice I sigma x ly k cap. Now we can write it as let's 2I outside, minus 2I outside, and it will be sigma z ly minus sigma y lz I cap plus sigma x lz minus sigma z lx j cap plus sigma x ly sigma sigma y lx minus sigma x ly k cap. So this is, we can sigma z ly minus sigma y lz, we have taken it as sigma z ly minus sigma y lz is ax. We have taken it as ay, and this is az. So here what we are getting is minus twice I A. So the first part is I h cut A, and second part is minus twice IA. So now putting these two values in the equation, where is the equation? So in this equation, so this is sigma dot L. The L is I h cut A, so we can write I h cut A and plus C into minus twice I A is equal to 0. So as we can take I and A common, so h cut plus 2C, h cut minus 2C is equal to 0. So this part is cannot be 0. So the second part will be 0. So here we can write h cut minus 2C is equal to 0. So 2C is equal to h cut, to C is equal to h cut by 2. So this, though our equation will be, the value of C is h cut by 2. So where did we put the value of C? So in this equation, so L plus h cut by 2 sigma should be the operator. So the solution is here, B. So this commutator part we have solved it. Now we will move to the next topic, which is operator, and we will solve few questions. There will be maybe 5 or 6 questions in that part. So next we will start that part. So thank you till now.